You're going to like this particular video. It's going to be a whole lot shorter than what we had in the last two with the Gauss-Jordan, but this is a way that you can check yourself, which a lot of students would like to know how to do. We're going to, I call it a magic key in a way because it is so nice. This is the rref, which stands for row reduced echelon form, but via the calculator. Now we're going to use this particular key to solve the given systems, and if it has an infinite solution, find the possibilities by using parameter. Remember, that's the one where we let the very last variable equal t, or a letter of your choice. So the first thing I need you to do is put this in your calculator. So let me go access my matrix over to edit. And the first one is a 3 by 4. And let's type it in. Notice my x sub 3 here is 0. Let's do second quit. Go access it one more time to double check. So there's 4, 1, 2, 5, negative 2, negative 1, negative 6, negative 5, 0, negative 4, negative 12, and 7. Let's just say, for instance, you did put in something wrong. The way to go change it is go second matrix, over, of course, to edit, get that particular one, matrix that you need, and you can cursor and go to the position that you need. Say that needed to be a negative 3. You can type in negative 3 and then quit, and then go access it again and make sure. Now here comes the rref. Second matrix, over to math, go up. We've been doing that, but here it is. There's the row reduced echelon form. So let's go up, hit enter, or press enter. You've got to tell it the particular matrix that you want this done to. Now what the calculator is going to do is the Gauss-Jordan, boom, all in one little quick step. There it is. So my solution is x sub 1 equals 3.25, x sub 2 equals negative 0.5, x sub 3 equals 3.25. Is that not a nice way to check yourself? Now you are going to have to complete a Gauss-Jordan. You can use this rref to check yourself, but if I ask for the problem to be done using Gauss-Jordan where I need to see those steps, I'm going to hold you to it. We need to know how to do that because a little bit later on, the steps that we use for the Gauss-Jordan we'll use for something else, and the rref key we won't be able to use. So this is just a way to check yourself. Let's try this one. So let me go to second, access the matrix, over to edit. This is a 3 by 4. So I've got 1, 1, negative 1, and 0. 2, negative 1, 1, negative 1. 2, 2, negative 2, negative 8. Second quit. Second matrix. 1, 2, 2, 1, negative 1, 2, negative 1, 1, negative 2, 0, negative 1, 8. And we just did the rref just a few seconds ago, and that recall feature works in this as well. Alright. Let's see if that's the matrix I've got here. Now, this would, the last equation, I would have it written as 0 equals 1, and that's not a true statement. That means one of these two planes is parallel, and that means they'll never hit. So this indicates no solution, because the last row corresponds to 0 equals 1, and that's not possible. And that's all I have to do to that one. Now let's look at this one. Second matrix, over to edit, and it's a 3 by 4. So 1, enter. I gotta go check it. Because guys, if you use this rref and you don't have your correct matrix in, you're going to come up with a solution that's not for this particular matrix. So please try to get in that habit. So second enter, row of zeros. Don't ask me why it jumped. If you wrote this out, you'd have x sub 1 plus x sub 3 equals 5. You would have x sub 2 equals negative 1. X sub 3, if you'll notice, I've got a 0 here. So my x sub 3 is going to be a t eventually. Okay? So x sub 3 is t. X sub 2 equals negative 1. Now remember, this was x sub 1 plus x sub 3 equals 5. If you move the x sub 3 over, it becomes a negative x sub 3. So either you could put t in now and then move it to the other side of the equation, but whichever way you do it, your x sub 1 will equal a negative t plus 5. So notice the row of zeros. This corresponds to 0 equals 0. Unlike the prior problem, this equation, and therefore the system, has infinitely many solutions. Since x sub 1 is expressed in terms of t, the variable t is called a parameter. I don't know if that needs to be x sub 1 or x sub 3. You better change that to x sub 3. I think I'll do that right now. X sub 3 is expressed in terms of t, and a parameter just means it can take on different values, over time. And we'll see that a little bit later. And that's it for this particular video. Thank you.